Hello everyone. So this is the third video in our first year patterns and sequences block. Let's look at the learning outcomes. So far you've looked at determining the next rule and extending a number sequence. You then took that into determining an nth term formula to find any term in the sequence, and you should have completed the worksheet that went along with that. And what we're going to look at today is this last bullet point here. Within a context, I can determine a formula for a pattern and use it to solve problems. So instead of it just being a random sequence of numbers and working out an nth term formula, there's going to be a context to our sequences today. And what you're going to have to do is use the context and the letters sort of given to you in the question. So let's pause a little. In fact, no. Before we get to that, what I want you to do is pause the activity, pause the video just now, and however we go at this starter activity here, just to check that you can still find nth term videos. So give the video a wee pause, and fill in the missing values in both of these tables. So let's go through the answers then. So what you should have for the first table, we'll call it table number 1. For the first table, we've got our inputs 1, 2, 3, 4, 5 and 6. We've got our outputs 3, 8, 13 and 18. And what you should have spotted is that we are going up in 5s each time. And if we're going up in 5s each time, that means that must be 23 and that must be 28. And also, when it comes to our nth term formula, if we're going up in 5s each time, then we must have 5n. We must need the 5 times table to get our sequence going up in 5s. Now you'll then test that. Let's get our correction term. Let's test it. Well, if the input was 2 and we need to get 8, well, if I did 5, what 5n would be equal to is 5 times 2. That's 10. But 10's too many. I don't want 10, I want 8. So what I would need to do is 10 take away 2 and get 8. And that take away 2 is the correction term. Okay, test it on another value if you want. Let's test it on 5. Let's do 5 times n. Well, n is 5 this time, so 5 times 5 is 25. Take away 2 is 23. Aha, that's what's in the table. Let's do it again for the second table. Table number 2. Inputs again 1, 2, 3, 4, 5 and 6. Our outputs are 7, 11, 15 and 19, and again you'd notice that we're going up with 4s here, so that would be 23 and 27. And for our nth term formula, it needs to be the 4 times table, 4n. So again, let's test it. Let's choose a value. So if the input was 3, then the output we should get is 15. So what does 4n give us? 4n gives us 4 3s is 12. 12's not enough. 12's not enough. I need 15 here. So we have to add 3, and that's our correction term. Okay. And if you wanted, again, you could just test it. If we had n equal to 4, then 4n plus 3 would be 4 times 4. Well, that's 16 plus 3 gives us 19. Hey, that's what we get. Okay, so that's a good wee starter activity. Hopefully you managed to get that right. If you didn't get that right, I suggest you go back and have a look through the last video again, because this lesson uses these skills to help us work out some formulas. But of course, the formulas will look a bit different, it'll be a wee bit harder to understand because there's going to be a context surrounding them. So let's have a look at an example. Okay, let's get the brain working here. What I want you to do is, I'm going to read this out to you, and then I want you to pause it, and I want you to give this some thought, okay? What we've got is a waiter in a restaurant is trying to work out how many tables he needs to seat 15 customers, right? Now, some information about the tables and the layout of the restaurant. The tables are square-shaped with enough space to seat 4 people. That's at each table. The layout of the restaurant is such that the tables will have to be laid out in a straight line and joined together. So how many tables do you think are needed? So pause it, give that some thought, see if you come up with the right answer, and I'll give you the right answer in a little minute and tell you how that relates to our sequences work. So give that a bit of thought. Okay, so what I'm going to do is I'm going to tell you the most common, when I normally do this with a class, there is a very common wrong answer I get. And I'm going to tell you what that is first before I tell you the correct answer, okay? So what most people think is that, well, if there's 15 customers and each table seats 4, then, well, 15 divided by 4 gives us 3, and 3 left over, so I'll need 4 tables. Yeah, okay. So that would be sensible. But 4 tables is the wrong answer, right? And the reason for that, if you think about this problem, right? If you give this problem a bit of thought, just by sketching out some ideas, then okay, so if we've got 1 table, right? 2 tables, 3 tables, and then 4 tables, right? Remember, it said in the question that the layout of the restaurant is such that the tables need to be laid out in a straight line and joined together. Well, if they're joined together, then you're not getting 4 people around the table anymore. You're getting 3 people around the tables at the end, and then 1 at each side here. So that's 4 tables. How many people does that sit? Well, that sits 4 across the top, 4 across the bottom. That's 8, 9 and 10, 1 at each end. So 4 tables is 10 people, not the 15 that we needed, right? So if you get to sort of thinking about it, right, then really what we need is, okay, we need for 15 customers, then what we need to do is try more tables in, won't we? Right, so you could keep sort of working this out, right? Well, what would 5 tables be? That'd be 1, 2, 3, 4, 5, 3 at each end, and then the ones across there. All right, so that's 5 across the top, 5 across the bottom, that's 10, plus 1 at each end is 12. So 5 tables. There's 12 people, so we're still not close enough. All right, let's try 6 tables. All right, so that'll be the same 5 as we had above. So 1, 2, 3, 4, 5, plus an extra table, 3 at the end. 1, 2, 3, 4, and then all the ones up here. So that's now 6 across the top, 6 across the bottom. That's 12, plus 2 at each end. That's 14 people. Right, so 6 across the top, 6 across the bottom is 12, 2 at each end is 14 people, 6 tables is 14 people. Now, you might have been able to predict that. You know, 4 tables will get 10 people. We worked out that for 5 tables was 12 people. Well, that's adding 2 and 2 again. So this is starting to sound like a sequence that's going up in 2s here, isn't it? So you would expect, or you would predict, that 7 tables would be the correct answer here, because 7 tables should give me 16 people. Yeah, by adding 2 again. Now you could draw it out, right? So we could have 1, 2, 3, 4, 5, 6, 7 tables, 3 each end, and then all ones across the top. So that's 1, 2, 3, 4, 5, 6, 7 across there, 7 on the bottom is 14, 1 at each end gives us 16. So that worked, didn't it? Right, so what we're seeing here is that every time we add a table, we create capacity for 2 more people. Right, now, what you might, obviously, what the waiter might do is he might have a little sheet of paper with this information sort of ready for him. If if he wants 10 people, he would use 4 tables. If he wants 12 people, he would use 5 tables, and he might have all that written out. Where this sort of thing comes in is you might consider a sort of computer programmer writing a computer program for the restaurant. you know, the whole point of sale system, or for the till and everything like that, might have a feature in there with bookings. You know, if you want a booking for 20 people, then you would need this many tables. And what the computer programmer might do is program into the system a little mathematical sequence or formula, and say, well, if you need this many people, then you put in this many tables, and the program would work that out for them. So having a sort of key knowledge of how these sorts of sequences are sort of made might help you in sort of other areas of the curriculum, right? If you think about some computer programming, for instance. And let's have a look at this in a bit more detail, okay, with some better drawings than the drawings that I've just made. So I've got a summary of the sort of first three values in the sequence here. One table covers enough for 4 people, 2 tables is 6 people, 3 tables is 8 people, and again you're seeing that adding 2 each time every time we add a table. Now that can be made into a sort of standard table similar to our nth term formula tables. And what we're going to do is put across the top row our number of tables. 1, 2, 3 tables. And on the bottom row, we're going to put that we have 4 people on the first table, 6 people on 2 tables, 8 people on 3 tables, and then you would start to predict, well, okay, so for 4, 5, and 6, then we would have 10 people, we would have capacity for 12 people for 5 tables, and for 6 tables with the capacity for 14. Okay, but again, you know, we sort of fall into this trap of, well, okay, I can work out how many are in 6 tables if I know how many are in 5 tables, because you know that you're just adding 2 on each time. But what if I had a crowd of, what if I had sort of 15 tables, right? If I had 15 tables, well, what kind of capacity does that give me? You know, how many people could I sit around 15 tables, for instance? Or conversely, I might ask, well, okay, I've got a party of 28 people coming. Well, how many tables would I need for 28 people? So what you want to be able to do for scenarios like this is come up with a formula. And the way to come up with a formula, because this is a nice, easy sequence, it's going up in 2s each time, then the formula is found in the exact same way you find a formula for your nth term, right? Just the difference is you have to use the letters T and P. Okay. Now, the first question that you'll ask yourself when you're building this formula is, should I have T equals or should I have P equals? Right? Now, there's a nice, easy way to work that out. What you always want is a formula that's equal to whatever letter's on the bottom row. Right? So whatever letter is on the bottom row, if it's P that's on the bottom row, as it is here, number of people, we're calling that P, that's in the bottom row, that's what my formula is going to be equal to. It's going to be P equals. Okay, we never have it equal to the value that's on the top row of the table. Alright, so let's get rid of T equals. Get rid of that as well. Now, what you might want to do if you're very good at creating the nth terms, then what you might want to do is come up with your nth term formula here. Well, it's 2n because we're going up in 2s, and if I wanted it for the second term in the sequence, then we would have 2 times 2 is 4. 4 is not enough, we need 6, so we need to add 2 to that. That's the correction term. So that's your nth term formula. Basically, a formula involving P and T here would be, well, the number of people must be equal to 2 times the number of tables, add 2. Right? So instead of using n, we're using t. Right? So a tidier way of writing that is p equals 2t plus, in fact, shouldn't really use lowercase. That's goes for any of you guys as well. Try and stick to the right case. So if it's capital T, use that. P equals 2t plus 2. Right? And that's our formula for this sequence. Now, how does that help us in the sort of two questions that I posed here? How could I work out the number of people, for instance, if I had 15 tables? Well, if I've got 15 tables, then that says that t is equal to 15. Right? So that must mean that the number of people would be 2 times 15 and add 2. So that's capacity for 32 people. Right? So that would be 32 in there. But what if I wanted to work in reverse? What if I knew the number of people that was coming in? So what if I knew that the number of people was equal to 28 and I wanted to work out what the number of tables were? Well, what that would mean is that instead of p equals 2t plus 2, then I would know the number of people was 28, and that would be equal to 2t plus 2. Well, hang on a wee minute. I've got an equation that I'm going to have to solve here. Now, we're going to be looking at equations in the next topic. Alright, but you should have done some form of equations at primary school. So I'm hoping that this is an equation that you will be able to solve. Perhaps not in the method I'm about to show you, but you might have your own method for solving it. But you just need to be able to solve the equation. If you can't in this lesson, please, please, please don't worry about it. What you will be able to do is go to the equations unit and go through the equations unit, which we will do over the coming weeks, and then you'll be able to come back to some of these questions once your equation solving skills is a little bit more improved. Okay, so let's have a little look here at how we would solve this equation. Right, well, there are two ways of doing it. Right, my preferred way for doing it would be by balancing the equation, and I'm hoping that this is something that you will have done at primary school. Right, now what we want to do is solve for t, and there's this add 2 term here that I'm going to deal with by taking it away, but remember equations are always a balance, so you take 2 away from both sides, and what we get is 26 equal to 2t, 2 times the number of tables. Now that's what 2t is equal to, so 1t must be equal to 26 divided by 2, and we get 13, and that's 13 tables. Okay, so if we've got 28 people coming, then we would need 13 tables. So that would be that value in there. Okay, so as I say, there are a couple of questions in the exercise that we'll get you to do as part of this video lesson. Most of the questions have got sort of two parts to it once you create the formula. The first part would be just using the formula in this way, and the second part would be using the formula in this way. We have to solve the equation. Right? If you can do the first part but not the second part, that's okay at this stage because you're going to solve equations later on in the unit anyway. Okay. Now let's do one more example. Right? That was pretty detailed and quite slow and methodical to get through. Let's have another look. Let's have a look at another example here. Right? So Mary makes necklaces in M shapes using silver bars. Okay, and we've got for one M shape, we've got 1, 2, 3, 4 silver bars. Okay, for two M shapes, we've got the same as before, 1, 2, 3, 4 silver bars, but we've added on 3 more. And for 3 M shapes, 1, 2, 3, 4 that we had, and the other 3 that we had, so that's now 7, and then we add on another 3 to get the third M shape. So that's going to be 10 if you're thinking about the table. Now what you can see is that for every time you add an M shape, you need 3 more iron bars. So that's your clue that your number of bars must be going up in threes, and you can kind of see that here. 4 plus 7 makes 3, 7 plus 3 makes 10, 10 plus 3 makes 13. Right, now what I would suggest you do is, in order to fill in the value for 15 M shapes, I suggest that you work out the formula, right? And if you work out the formula, then you can go back and fill in what it is, what the amount of bars you need for 15 M shapes. So our formula, remember the formula is always the letter on the bottom row, so it's going to be B equals, right? Write down a formula for calculating the number of bars, so it's B equals. Now, what's our multiplier? We're going up in threes, so it's got to be 3M. Test it, right? For 2M shapes, 3M would be equal to 3 times 2, that's 6. 6 isn't enough, I need 7, so my correction term is plus 1. And that's the formula, folks. Okay? What that means is that you can then come back to this value in this box and say, well, if it's 15M shapes, then the number of bars would be 3 times 15 and add 1. Well, 3 15s is 45, add 1's 46. And that's you filled that bit in. Okay. So, I'm going to leave it at that. Okay. Having gone through that, the exercise that I'm going to get you to do, we're going to have a wee look at the Level E textbook. So to get that off the Google Classroom, and it's chapter 11, exercise 4, and I want you to do all of the questions, and that spans from pages 139 to 143. Okay, now sounds like a lot of pages with a lot of questions, not as many as you think. There's just a lot of diagrams to go with each question, so they take up a lot of pages. This is really tricky stuff, right? As far as the sequences unit goes, this is as tough as it gets, right? If you are finding this quite difficult, please speak to your teacher. Drop your teacher a line, an email, and say, I'm finding this quite hard. Can you give me a bit of help? Okay, please do. It's quite tricky. It's hard. It would be hard enough to do within the classroom. It would be, I'm sure it will be that wee bit more difficult just by watching a video and doing it through distance learning. So please, if you're stuck, email your teacher, let them know you're stuck, and they can give you a little bit of help. Okay. I'm hoping the video has done enough of the explaining for you. That is the end of the sequences unit. So you'll have a good few days to get through this exercise, and if you manage this well enough, then you'll have done very well with this unit. Okay, so thank you very much for listening.